So we've done plenty of quadratic graphs. Now let's work on cubic graphs. In cubic graphs, you're going to have two scenarios predominantly. One scenario is where your graph intersects the x-axis at 3 different points. Another scenario is where one or maybe two of the points are recurring, meaning if you were to draw it, it can go up and then it can just touch there. Or it could potentially only touch at one point like that. So it can have 3 roots, it can have 2 roots, or it can have 1 root. That's the options you have with a cubic graph. The way you work it out is going to be the same as a quadratic. So you're going to make your y equal to 0 and then you're going to solve. So looking at the 3 that I've got on the board, the first one, if we were to make the brackets equal to 0, then what would x be equal to? For one of them, it's going to be -1, and for the other one, it's going to be just 1. But you're going to have that 1 2 times because it's x minus 1 squared. So you can think of it like this. So x equals 1, x equals 1, x equals -1, which means x equals 1 is a repeated root. So because it's a repeated root, it's only going to touch x equals 1, and it's going to intersect. So it's going to go through x equals -1. So if we were to draw it, -1 is here, 1 is there, it's going to go through -1 and it's just going to touch here, like that. All cubic graphs follow this shape where it's an up and down wave kind of motion. Okay, that's part A. Part B. Y equals x cubed minus 2x squared minus 3x. In this case, you want to first factorize. So if we take the x out, we're left with x squared minus 2x minus 3. And now you're going to factorize the bracket. So when you factorize the bracket, you get x minus 3 and you get x plus 1. This is equal to 0. So can you work out what the values of x are going to be? One of them is going to be 0 from that. From this bracket, x equals 3. And from this bracket, x equals -1. You don't have any repeated roots, meaning all of those are going to be intersections. So if I draw it, -1, 0, and 3, it's going to go through all of them, like that. Cool. Last one. We make our bracket equal to 0. So what is our x going to be equal to? 2. And that's the only solution, which means that is going to be the point where it intersects. Because remember the drawings that I put at the start, you've got 3 roots, 2 roots, or 1 root. In that 1 root, it only goes through that 1 point. So it's going to look something like this. It's not an obvious up and down motion, but if you notice, it still kind of follows the same-ish shape as the other two. But that's how you do cubic graphs. So I have put a question on there. I want you to try A, D, and J for me, please. Okay, so with A, you are first going to factorize it. And when you factorize it, you should get x bracket x plus 2 and x minus 1, and then that's going to be equal to 0. You take the x out first, you're left with x squared plus x minus 2, and then that you can factorize as x plus 2 and x minus 1. So your solutions for x would be 0, minus 2, and 1. All of them are going to be intersections. So something like that, where this is minus 2, that's 0, that's 1. Make sense? Okay. D. After factorizing, you should have got x, 3 minus x, 1 plus x equals 0. Same thing as before, you take the x out and then you factorize into double brackets. Your intersections will be 0, 3, and minus 1. Now, in this case, it's minus x cubed. So instead of going like this, it's going to go in the opposite direction. Like that. Where this is 1, that's minus 1, 0, and 3. That's what happens when you have a negative cubic graph. It flips. It's like a mirror image. Okay, last one, J. When you factorize J, you would take out the x squared, x minus 9 in the bracket, which means x equals 0 and x equals 9. This is a repeated unit though, so this is just going to touch. So when we draw, it's going to look something like that, where this is 0 and that's 9. There you go. That is how you do cubic graphs.